Welcome back. We are solving the circuits using nodal analysis techniques, and we are analyzing the circuits with the dependent sources. So this is our next example. Uh, Here we have a dependent current source again, but now this dependent current source is basically in the form of a voltage. Okay, so it is dependent on the voltage value Vx. Okay, and this Vx value is basically the voltage at this node. Okay. And the question here is using nodal analysis find the value of V naught. Okay, so V naught is basically the voltage drop across this 12 kilo ohm. Okay, here. So let's see how we can solve such circuits. So first question is identify the nodes of the circuits. So we can notice here that we have two nodes. One node is this one where this 2 milliampere 3 kilo ohm and this dependent current source is connected. Okay, we can label this as Vx, okay, V1, V2, V3, okay, whatever you like. Okay, because like that current source depends on the value of Vx, so that's why this has been labeled as Vx here. So we can even use the same notation. The second node is this one, okay, where this 12 kilo ohm and this current source are connected. So let's label them as V2, V3, V4, or whatever you like. Okay, for example, I can label this as Vy. Now let's write the equation for these two nodes. So what will be the equation for the Vx? All currents are leaving. So this is leaving. So that will be, this is leaving and this is leaving. Three currents are leaving from this node. So first one is 2 milliampere. That is basically incoming. So we can put minus 2 milliampere plus the current through 3 kilo ohm. That will be this node voltage. Vx minus this node voltage 0 minus 0 divided by 3k. Okay. So minus 0 basically this is there. Okay, but for the simplification now from onwards I'm removing this one. Okay, just to make it simple. Then this current, okay, this current is basically what? A dependent current source with the value of Vx over 6000 is equal to 0. Let's write the equation for the node Vy. Okay, so what will be the current started leaving from this node? So the current from this node, okay, that will be this current which is leaving. So I can put minus Vx over 6000. Then this current which is leaving, that will be basically what? This node voltage which we have labeled as Vy minus this node voltage which is 0 divided by 12k. Then this current, okay, through this branch. Again, what is the voltage here? Vy minus 0, second node voltage divided by 12k, and this comes out to be 0. Okay, equal to 0. So we have got, okay, two equations, okay, and two unknowns. Okay, like we have Vx unknown here, and we have Vx here, and we have Vx and Vy here. Okay, so here as compared to the example 3 and 4, where we have a dependent current source in the form of a current. Okay, the control variable was a current. Okay, and we write the equation for the control variable here. But here the dependent current source is basically in the form of a voltage, and we have already basically written the equation. Okay, and we know that we label this as Vx, and we have already got that in our equation, so we don't need to rewrite another equation for the control variable. So we will just simplify these two equations. Okay, so here I have basically 6000. Okay, so just to make it simplify for the analysis here, I can simply rewrite this as like Vx over 3k, and this 6000 can be written as basically 6k. This is just a simplification step. Same thing we can do here. So we get minus Vx over 6k, Vy over 12k, then again Vy over 12k is equal to 0. Okay, why I did that? So that I can simplify this. Okay, now I can multiply with 6k, 6k, y 6k, it's a maximum value, common multiplier of the denominators. So 6k times 2, I will get minus 12, milli and kilo will be cancelled. Then I have Vx, so 3k, 6k divided by 3k will have 2, so plus 2 times of Vx then 6k will be cancelled, plus Vx is equal to 0. So we have 2Vx and Vx, that will be 3Vx is equal to 12. So value of Vx comes out to be 12 divided by 3, which is basically 4 volt. Let's come here. We can multiply this again with the 12k. Why 12k? Common multiplier, okay? All right. So 12 divided by 6, we have 2. So that will be minus 2 times of Vx. This 12k cancelled, plus Vy again cancelled, plus Vy is equal to 0. So what we have here, minus 2 times of Vx. We have already found the value of Vx. What is that value? That is basically 4 volt. So let's put it here. So minus 2 times of Vx, 4. Vy, that will be 2Vy is equal to 0. So minus 4 times 2, that will be 8. 2 times of Vy is equal to 0. So what we have here, students? Vy will be basically what? 8 over 2, that comes out to be 4 volt. Okay. So we have got the values of Vx. We have got the value of Vy. That is both for this case comes out to be basically 4 volt. Okay. So let's just put them here on the circuit. So Vx is 4 volt and Vy, okay, this whole branch is basically 4 volt. Our question was that we need to find the V naught. So where is the V naught? V naught is a voltage drop across, okay, this 12 kilo ohm branch. Okay, so if you look at this circuit, this V naught is basically nothing. Okay, it's just like the voltage drop between this node and this node. So voltage drop between this node and this node is basically Vy. So we can say that V out is basically simply Vy, and that comes out to be simple 4 volt. Thank you so much.